recording? Yes, yes. All right. Sure. Okay. So, I don't want to do all of them. I just want to do the ones that are necessary. Okay? So, let's take a look. Raise your hand if you'd like me to do number 3. Okay. How about number 4? Okay. Number 3 and number 4. All right. I'll do number 3. That's how we'll start. Okay. And we're just going to plot along through this. I don't think I want to take the whole hour because I'd like to move on, but we'll just do what's necessary. Take a look. First step, always rewrite the radicals. So this whole thing, 27x to the third to the fourth power, is all within this bracket to the 1/3 power. Okay? Now, I've got the power of a power, so what do? I multiply the exponents. You see, that 4 and that 1/3 become 4/3 because I'm taking the power of a power. See that? Question?
Can you just skip the step and just make it 4/3?
Totally. You can skip that step completely. If you can see that this is just going to end up as 4/3, you can just write it as 4/3. That's fine. But if you can't see that, then you rewrite the radical as 1/3 and go forth from there. Okay. Now the danger with just writing this as 4/3 is if you have like a product in here, you've got to apply that 1/3 to everything. Okay. So you have to make sure you understand. Yes, ma'am.
You can't multiply 4 to 3, right?
Not yet. Okay. So that's the first step. The next step now is I have this exponent and I have a product inside. So I have to apply that exponent to both of those terms. So it ends up being 27 to the 4/3 and x to the third to the 4/3 power. Okay? Now, if I want to get 27 to the 4/3 power, I split that up, remember? It's the cube root of 27 to the 4th power. And this now, I have x to the third to the 4/3. I have an exponent and an exponent. What do? I multiply them. So it becomes x to the 3 times 4/3. Well, that's just x to the 4th, right? Now I just simplify. The cube root of 27 is what? 3. 3 to the 4th, x to the 4th. 3 to the 4th is 3, 9, 27, 81. So it's 81x to the 4th. You see? All the steps. We just take it step by step. For the record class, I'm being super rigorous and methodical with the way I'm teaching you this stuff. You may see places where you can just skip steps. For instance, if you could just do 27 to the 4/3 power, you could just do it. Oh, cube root of 27 is 3, then to the 4th, okay? Fine. But these are all the steps, so it makes it easy to see. Any questions on these? No? Okay. All right. I'm recording this video, guys, so remember if you miss something, don't worry. So I'm going to skip number 4 because it's basically the same, and I'll do number 5. Okay. So this one, I rewrite the radicals. Okay. So it's 8y to the third, the 4th power, that's all to the 1/3, and 8y to the third to the 4th power, and that's all to the 1/6. Okay. Now I have a power raised to a power, so I multiply them. Bless you. 8y to the third. All of that is to the 4 times 1/3 or 4/3 power. then 8y to the third to the 4 over 6, which simplifies to 2/3 power. Now look, I can make my life really easy right now if I want to. What do you notice about both of these things in parentheses? They're the same. So effectively, this is just x to the 4/3 times x to the 2/3. And in this case, what do I do with the exponents? Add them, right? So this just becomes 8y to the third to the 4/3 plus the 2/3, right? See? Well, 4/3 plus 2/3 is 4 plus 2 is 6 over 3 is just 2, right? So this is 8y cubed, all that squared. You see? Okay. Now I have an exponent and I have a product inside, so I take that exponent and I apply it to both. So this ends up being 8 squared times y to the third squared. Right? 8 squared is 64. Y to the third squared, a power to a power, is y to the sixth. You see how it's the same rules over and over and over and over again? This is why we need to practice, okay? You might see it the first time and see like, I got it, I understand the rules. Then you see the questions and you're like, but I can't do the questions, right? You apply your brain, you do the best that you can, you come back into class, here we go. We're doing the questions. Now you get it. By the time you get the test, as long as you're paying attention, by the time you get the test, you'll be like, I've done this 50 times, okay? All right, next one. So the answer for the record to this one was 64y to the sixth. Okay, next one. This is very simple, though it looks like, it's like, wait, what? Okay. They're trying to trick you. What's 0x? 0. What's the answer to this? 0. Okay, it's just 0. Okay, let's do this one now. I might actually just do all of them. I don't know. We'll see. It's worth it. You know what? It's worth it. Okay. So, all right. Let's take a look at this. You see now, Ms. Dival, right? Here, it's like, whoa, wait a second, right? So we rewrite the radicals, right? It sounds fun when you say it, anyhow. All right? So rewrite the radicals. 2x squared. Then this, instead of 2y, square root of that, it's 2y to the 1/2. And all of that is within a square root, so all of that is 1/2. Okay? When I rewrite it like that, automatically I'm like, okay, that looks a little bit more manageable. Okay? Now, I can do these in different orders if I want. Okay? But I think the way I'm going to do it is I'm going to start with the outside. Okay? I could apply these exponents in, and then work with it. But I think what I'm going to do is I'm going to apply this exponent on the outside first. I have a product in here. I have this exponent. I apply it to both of them, you see? So this is going to become, it was 2x squared, but now it's 2x, 2 times 1/2 is just 1, right? So 2x to the first power. And this was 2y to the 1/2, but now it's 1/2 times 1/2, so it's 1/4. You see? So this just kind of becomes, well, 2x to the first power is just 2x, right? Now I have this 1/4 on the outside, so it's going to apply to both of these terms in the product. You see the same rule over and over. Okay? And that's going to become times 2 to the 1/4 power times y to the 1/4 power. You see? Okay. Now, this looks kind of weird, but I assure you that it's very straightforward. Okay, I have a 2 here and a 2 here. It's not like an x or a y or a z, so it's like, wait, do I treat them the same? Yes, you do. Okay, so this isn't just a 2, it's a 2 to the what power? 1. All right, so I'm going to reorder this. It's 2 to the 1 times 2 to the 1/4 times x times y to the 1/4. Do I have to do anything else with the x and the y? No, I'm done. There's nothing else, right? But this 2 to the 1 times 2 to the 1/4, I have a product of two things raised to an exponent. What do I do with the exponents? Add them. So it's 2 to the 1 plus 1/4 times x y to the 1/4. 1 is 4/4. 4/4 plus 1/4 is 5/4, or 5 over 4. 2 to the 5/4 power x y to the 1/4. Now, here's the thing, class. This is a number, right? Potentially, we could get an answer for this, right? 2 to the 5th, but then to the 4th root. We could do that out, right? 2 to the 5th is 2, 4, 8, 16, 32, right? And then we could look for the 4th root of that, right? Think, okay, what's the 4th root of 32? It doesn't have a nice and easy one, okay? So you would need a calculator for this. What's the clue? The clue is I should try to take the 4th root first, right? What's the 4th root of 2? Some decimal, right? Okay, I can't take the 4th root of 2, so I just leave it like that. Okay, long story short, if I just confused you, don't worry. The point is you just leave it like that. And why? Because if I tried to break that up, 2 to the 1/4, and then raise that to the 5th power, do I know the 4th root of 2? No. So I just leave it. It's 2 to the 5/4 power. Okay? I could rewrite this in radical form, right, class? This would be 2 to the 5th, the 4th root of that, or just the 4th root of 32. You guys understand that? Okay? I'm just rewriting it in radical form. I could. I don't have to. I will accept this as your final answer. You guys understand that? Okay? All right. Any questions on that? Okay. All right, let's continue. Number 8. Okay, same deal, rewrite the radicals. Okay, 8x to the 1/2 over 16x to the 1/3. All right. Now, there are a lot of ways that I can do this. Okay? But there's something, and I'm glad I'm going over this, because I didn't really show you this. All right? I can't work with 8 and 16 because those are different numbers. All right? So what I'm going to turn them into is powers of 2. All right? 8 is 2 to the what power? 3rd. X to the 1/2. And 16 is 2 to the what power? 4th power. Times x to the 1/3. You understand? Okay. Because now I have the same bases. If I work with 8 and 16, first off, I would end up with the square root of 8, which is what? I don't know. And the cube root of 16, I don't know that. Right? So I can't work with those. So I've got to change it to bases being 2. Now that I've changed that, what do I do with this exponent? Distribute it in, basically. Yep. And same with this one. So it's 2 to the 3 times 1/2 is 3/2. X to the 1/2. All over 2 to the 4/3. X to the 1/3. Okay. Now, if I write this together like that, it can seem confusing. But if I write it separately as two different fractions, It makes it a little easier. What happens if I've got a base raised to a power over the same base raised to another power? What happens? What do I do with the exponents? I don't add them, I subtract them. So this is equal to 2 to the 3 halves, or I'll do it right below it so you can see, is 2 to the 3 halves minus 4 thirds times x to the 1 half minus 1 third. Okay? And then you're just talking about subtracting these fractions. So 3 halves minus 4 thirds, I have to get them common denominator. So 3 over 3 and 2 over 2. It becomes 9/6 minus 8/6, which is just 1/6. So this is just 2 to the 1/6 power. And I can leave it like that. Okay? Multiplied by x to the 1 half minus 1 third. 3 over 3, 2 over 2 becomes 3 minus 2 over 6 equals 1/6. X to the 1/6. Okay, and I'm done. That's the answer. That's the final answer. You guys understand this? Okay? Yes, ma'am. Good question. Class, do I always need the same base? Yes, if I want to work with them like this. If I want to work, if I left, I could have done 8 to the 1 half and 16 to 1 third, but then I couldn't have done this extra step because they would have been different bases. Question or just stretching?
No, just stretching.
Okay. Any other questions? Okay. All right. Next one. Okay, 0x to the 1 third. What's the answer?
0.
Good. All right.
We already did this one.
No, we didn't.
We didn't do this one.
Yeah.
All right.
Never said that.
All right. 10 to the 1/4 power. 10,000 to the 1/4 power, guys. It looks hard, but it's actually just arithmetic. The 4th root of 10,000 is what? Just guess. 10. 10, 100, 1,000, 10,000. Good. So this is just 10z plus the square root of 10,000 is what? 100. 100 times 100 is 10,000 plus 100z. What's 10z plus 100z? 110z. 10z. That sounds like a fun name.
It's like a country.
Oh. Okay. 10z. Okay. 10z plus 100z equals 110z. That's the final answer. You see? What? Okay. Shh. Let's focus. 10,000 to the 1/4 power is just the 4th root of 10,000. 4th root of 10,000 is just 10. So this is just 10z. 10,000 to the 1/2 power is the square root of 10,000. Square root of 10,000 is 100. So this is just 100z. 10z plus 100z is 110z. Okay. All right. Question? Question? Anybody? No? Okay. All right. This one. I don't want to do this one.
No, we need to do this one.
All right. Fine.
This one I got 17 over 2 is.
I am not going to put one like this on a test because it's arbitrarily
Alright,
hard.
then go past it.
Yeah, okay, fine. It's so much more challenging than all the rest of them for like no reason.
Things that are on the test.
What?
quizzes, I need.
Okay. What was that? No. I'm not going to do this one either because it's just, again, it's just these two arbitrarily harder problems.
Testing questions.
Okay. Shh. I'll do number 12. I'll do number 12 because I'll feel guilty if I don't. So let's do it. Thank you. Aww.
Praise God.
Praise God. Amen. All right. Shh. So what do I do with this power? I have 1 over 125 x to the third, all to the negative 1/3. What do I do with that power?
Distribute.
Distribute it in. Okay, bam, bam. I get 1 to the negative 1/3, but what's 1 to any power? Just 1. Over this whole thing, 125 x to the third to the negative 1/3 power.
They like kiss each other out. Exponents.
Now, what I should do, class, I've got something to a negative power, so I turn that into 1 over
Pause for
125 x to the third to the positive 1/3 power. Okay.
That's what it is.
And then I end up with, because I don't like this fraction within a fraction, 1 divided by 125 x to the third to the 1/3 power. Well, that's multiplied by the reciprocal, so it's 1 times 125 x to the third to the 1/3 power over 1. You don't have to write out all these steps. Guys, honestly, if you have 1 divided by a fraction, you just flip the fraction. Okay?
What
If-
happened to the top part?
This part,
No, all the way to the right, and then you go down to the bottom.
1 divided by the fraction. Just another way of writing it. This is 1 divided by this fraction.
And
1
that's where you're doing.
divided by the fraction, exactly. Multiply by the reciprocal, I get 125 x to the third to the 1/3 power. Honestly, class, these steps are super unnecessary. If you have 1 divided by a fraction, just flip that fraction and bring it to the top. Okay? You see what I ended up with? I just spent a lot of time to just like flip that fraction. Okay? Okay, so now I have this exponent on the outside. What do I do with it? Distribute it in. Okay, I get 125 to the 1/3 power. X to the 3 times 1/3 is just x to the 1. What's the cube root of 125? 5. 5x. Keep your brains in check. We got this. All right. Okay. Shh. We're clearly going to do this all hour, so just sit back, relax, and enjoy the fun. All right. No. Love you, man. Okay. Five x. The answer to this was 5x. Shh. Let's pay attention. Now this one. Whoa, this looks super different. Okay. I have the exponent of a power, but even before that, look what I have. I have the same bases, 2x to the x and 2x to the 2x, right? So I can just combine them, right, into 2x to the x. What do? I add them. So 2x to the 3x power, all raised to the 1 over x. Now I can take this exponent raised to an exponent and I multiply them. It becomes 2x to the 3x times 1 over x. What happens with the x's? They cancel. And it just ends up as 2x to the 3rd power. 3x divided by x is just 3. I could have written this a different way. 3x over x. Well, here it's 2x raised to the 3x power. And so I'm not distributing really, I have a power to a power, so I multiply them. Okay, so it's 2x to the 3rd power. Now I distribute these in, so it becomes 2 to the 3rd, x to the 3rd. 8 x to the 3rd. And that's my final answer. You guys understanding this? You guys following the rules here? Okay. Shh. All right, let's keep it moving. We did 14, yes. Okay. All right. All right, we can get through this, guys. We can get through this. All right. Okay. X squared y to the third power. First thing, I rewrite the radicals. X squared y to the third power, y to the fourth. It's written the 2 there. It usually wouldn't, but it's to the 1/2 power. Okay? Now I take these powers on the outside and I bring them in. X, this becomes x squared to the third power is x 2 times 3 is 6. This is just y to the third. This becomes y to the fourth times 1/2 is y squared. I then have x to the 6, y to the 3 plus 2, or y to the 5th. That one's done. Okay. All right. Questions on that? Questions? Remember, guys, I'm videotaping this, so you can always go back to it. Okay. Next one. Okay. Now, class. I've got powers to powers here on the top and the bottom, so I just multiply them. This becomes x squared y, 4 times 1/2 is 2, over x squared y, 1/2 times 4 is 2. I have x squared y squared over x squared y squared. What is that?
1.
1. See? Okay, math. All right, let's move forward. You see how crazy that looked and how simple it actually was? Okay, look, this is an easy one. Let's just do it quickly. Okay, I have all these things, but it's just raised to a power on the outside. What do I do with that power? Just distribute it in, right? X to the 1/8 times 8 is x to the 1. Y to the 1/4 times 8 is 2. Z 1/2 times 8 is 4. So it's x, y squared, z to the 4th. Okay, done.
Another one right.
Nice. Okay, let's keep it moving. We're almost there. Ooh, look at this one. Yes. Let's look at this one here. Okay, we got to rewrite the radicals here. So, this whole thing becomes z. Look, I got to write them all kind of because it's kind of crazy here. Is this whole thing to the 1/2. Z is on the outside. Then it's another thing to the 1/2. Y is on the outside. And then x to the 1/2 right there on the inside. You see that? Okay. All right. It's kind of crazy looking. I'm sorry. Okay. I'll rewrite this with like a square bracket. Okay. And then this I'll do like a squiggly bracket. And then this on the inside actually doesn't even need a bracket because it's just x to the 1/2. You see? You guys see this now? All right. I just keep bringing it in. Okay? 8. It's this whole thing to the 1/2 raised to the 8th power. So I can eliminate that first one pretty quickly. And then it just becomes z, y, x to the 1/2. This to the 1/2 power, and then 1/2 times 8 is 4. You see? You guys see this? It's a little bit tricky looking, but okay, I take that 4, I apply it to the z, and this whole thing raised to the 1/2. So it becomes z to the 4th times this thing, y, x to the 1/2. 1/2 times 4 is 2. Then I take this 2, bring it in for the y and the x. It becomes z to the 4th, y squared, x to the 1/2 times 2 is 1. So rewriting it's x, y squared, z to the 4th. Okay? You understand? Guys, that's like arbitrarily tricky, but it's good to be able to understand it. Yes, ma'am.
So for this one, the x, is it 1/2 times 1/2?
Right.
Oh, wow.
I worked from the outside in. You could have worked from this inside and then gone out, but I worked from the outside in.
Oh, you can do that.
Yeah, either way would work. Okay. All right.
It's Sebastian's birthday.
Is it?
Birthday.
Really?
Yeah.
Aw. And he got his math book back today. Huh? How about that?
Yay.
Okay, let's sing him a happy birthday. Ready? How old are you, sir? 17. He's also like a killer on the volleyball court, I will say. He was 17.
Wow.
Yeah. He was just like aces, like just. Woo! All right. Okay, so let's sing him a happy birthday and then we'll splash him. Ready? 3, 2, 1.
Happy birthday
to you.
Happy birthday to you. Happy birthday to you. Happy birthday to you.
And then Mr. Henry will be proud of us. God's blessings on you. Splash! God's blessings on you. Splash! God's blessings on Sebastian. One more splash! God's blessings on you. Splash! Bless you, brothers. All right. Amen. Thank you. Yes. Go quick. Yeah. All right. Shh. Okay. All right. We're almost there, guys. We're almost there. We're almost there. All right. Let's do this. We got this. We got this. Okay. All right. X to the 10th. All right. We got to rewrite the radicals, right? X to the 10th to the 1/5 power over x to the 8th to the 1/2 power. This is pretty simple, actually. Bring that in. Bring that in. X to the 10 over 5 is 2. Over x to the 8 over 2 is 4. I then have a quotient, so I subtract the exponents. X to the 2 minus 4 equals x to the negative 2, which is fine. You can leave it like that. You can also rewrite it as 1 over x squared, but it means the same thing. Okay? Does that make sense? Yes?
Sir.
Okay.
So wait, you can leave it as an x to the negative 2.
Negative 1, yeah, negative half. Negative 2, yes.
We
Yes,
have
ma'am.
to change it.
If you can tell me what the square root of 196 is. Shh, no one help her. Square root of 196.
I feel like it's 32.
No, I'm sorry. I'm sorry.
14. It's 13.
It's 14.
14.
It's 14. I'm sorry.
Already said the first
I'm sorry. I'll still let you go. Go ahead. Go
What?
ahead. I know. I shouldn't.
Good luck.
All right. Shh. Okay. All right. Now, I think not the best one to go to, but it's okay. All right.
Oh my gosh, what is this?
All right. First step, rewrite the guys, look, it looks crazy, but it's not. Okay? It's just a bunch of steps. X to the negative 8, 1/4 to the negative 1. Okay, rewrite the radicals. X squared to the 1/3. Let's be quiet. X to the 4th to the 1/6. It looks crazy, but it's not. Look, these are all just exponents raised to exponents. So I could just multiply all of them. Negative 1 times negative 8 is 8. 8 over 4 is 2. So this is just x squared. Multiply these two. It's just x to the 2/3. Multiply these two, x to the 4/6 or x to the 2/3. Well, that's convenient. Those just cancel out. This whole thing is just x squared. That's it. See? Yeah, math. Okay.
Wait, so
Yeah.
So I just multiplied all of these. because it's just power raised to a power raised to a power, so just multiply them all. See? Multiply them all, I got x squared. Negative 8 times negative 1 is 8. 8 over 4 is 2. Multiply those two, it's 2/3. Those two is 2/3. Those cancel out, I'm left with x squared. Okay? Alright. Moving forward. Can someone get the door, please? 2 more left. Two more left. Okay. All right, rewrite the radicals. It's x squared y to the 4th power. Then it's y to the 1/2. And then the square root, so again a 1/2. All right, I distribute that power in. It becomes x to the 8th, y to the 4th. I have a power raised to a power, so I multiply them. It's y to the 1/4. Okay. I end up with x to the 8th, y to the 4 plus, I add them, 4 plus 1/4, or x to the 8th, y to the 4 is 16/4, so this is 17/4. Okay. 4 plus 1/4 is 17/4. Any questions on that one? Okay. Remember, this is all being videotaped. And then, like, randomly at the end, they have this one that's kind of easy. All right, let's see. All right. So this is just y to the 1/4. It's in a square root, so it's 1/2. And then 8 on the outside. Again, it's just powers of powers of powers, so I multiply them all. 1/2 times 1/4 is 1/8. 1/8 times 8 is 1. So the answer is just y. Okay. That's it. All right. Simple as that. All right. These ones were just simple because you just plugged them in. Okay, so we're not going to go over those. Look, guys, this was we've now like gone over this. Guys, we're gonna have a quiz on this next class.
Oh, wow.
Wow.
Yep, you know I'm gonna actually help tomorrow.
Health class is today.
Wait, so tomorrow we have a quiz.
Lesson 3.2 and 3.1.
I'm gonna actually help today.
Guys, for the record, in case you want to know my secret of when quizzes are going to be, look at this. Unit 1, we had a quiz after Module 1, right? And a test after we were done with the unit. Unit 2, we're having a quiz after Module 3. And then I'm going to combine Module 4 and Module 5. But generally speaking, you can assume that every module, we're going to have a quiz. Okay? So 3.2 and 3.1. 3.1, 3.2. Okay? Look, understanding rational exponents and radicals, we're just kind of a part of 3.2 anyway. Okay? So you can expect most of the quiz is going to be on what you just went over. Okay, so we taught the lesson, you had the homework, now we went over the homework. We're going to have a quiz next class, which
After school is
for you guys, yeah, helps classes today after school. All right.